right, so problem 10, very back page, looks like this. We need to find the translation vector. We are going to find the vector that mapped triangle LMN to triangle L prime, M prime, N prime. When we are given a vector, what does the first number tell us? Left and right. What does the second part of the vector tell us? Up, down. When we are looking at the two shapes on the graph, we need to know which one we started with and which one is the new one. So which one, the one with primes or the one without primes, is the original one? Without primes. So this one right here, we call the pre-image. It is the original. That means the one over here that has the primes is the image, or it is the new one. We need to pick out a pair of corresponding points, so M and M prime, N and N prime, L and L prime, and we're going to count from one to the other. So I'm going to pick out M and M prime, because that's a match. Those are corresponding. They go together. We start with the original one. You start from the pre-image, and you count your way over to the new one. So to get from M to M prime, I'm going to do left, right first, because that's the first number in the ordered pair. How far left or right do you go from M to get to M prime? 5 units. Left or right? Left. 1, 2, 3, 4, 5 units left. How do I indicate in my vector that it went left instead of right? Negative. So we put a -5 here. That tells me that we went left 5. And then I still need to go which way to get from right here to M prime? I need to go down 2. So how do I put that in the vector for down 2? -2. It is really important that you know which one you are starting at, the original, and then count your way to the new one. Count your way towards the one with primes. If you get them backwards, you'll get the right 2 digits, but you'll have the wrong signs on them. So you'll get the right digits but wrong signs if you start with the wrong one. Make sure you start with the pre-image, the one that does not have primes. All right, what other questions would you guys like for me to work through? Number 9? Absolutely. Thank you. I have you at the table in the back that has all the markers. Problem number 9. So now we're looking at symmetry, line symmetry and rotational symmetry. If I fold the heart across this line, do the two sides match up perfectly? No. Is there anywhere that I could draw a line and fold it over that line that the two halves would match? Yes, if I go vertically, straight up and down. So yes, we have line symmetry. That is the only place that I could put a line and make the two halves identical. So the heart has one line symmetry. For rotational symmetry, you can use tracing paper. You can use tracing paper on any parts of the test tomorrow, anything that you want to. But for rotational symmetry, I would put a piece of tracing paper on top of my heart. I would copy the heart onto my tracing paper, and then I'm going to start rotating it around and looking to see if it matches up with itself anywhere before I get back around to where I started. Is it matching up with itself anywhere so far? No. In fact, I have to go all the way around back to where I started before it matches up. So this does not have rotational symmetry, which means order is not applicable and magnitude is not applicable. What about the four-leaf clover? Can I go through the four-leaf clover vertically like we did with the heart? Yes. Are there any other lines of symmetry for the four-leaf clover? Across, we can go horizontally left to right, and diagonally, we can do both of our diagonals. So yes, we have line symmetry here. We have four line symmetry. For rotational symmetry, I'm going to trace around the four-leaf clover on my tracing paper. And then I'm going to start to rotate it and see if it matches up with itself anywhere. So as I start to rotate this shape around, I notice that when I get right here, it matches up with itself. So there's my first stop. I would stop and count 1 here. And then I'm going to continue to rotate. We rotate all the way around until we get back to where we started. But when I get down to the bottom, it matches up with itself. So now I count 2 because I've made 2 stops. So far we have order 2. Continue to rotate around. It matches up with itself here. So now I'm up to order 3. And then I continue rotating until I get back to where I started, right up here. So I was able to make 4 stops. So yes, we have rotational symmetry of order 4. What would the magnitude be? What would it be? 90. How do we find the magnitude again? We divide it. We do 360 divided by the order, divided by 4. What else would you guys like to see? Number 7? Absolutely. We can go and look at number 7 next. Number 7 says consider line segment AB with endpoints A, -1,8, and B, -5,6. And the first thing they ask me to do is to graph that line segment. So we're going to plot point A at -1,8 and point B at -5,6 right here. We're going to connect those 2 line segments together. In part B of the question, it says draw A prime, B prime after the translation along, and then it gives me this vector. It's got those angled brackets. That means a vector. It's telling me how to move my points. This first number, the -4, means to move the points which way and how far? Left 4. First number is always my left-right number. That's the x part of a normal ordered pair. The x-axis goes left and right, so that first number is left-right. What's the 2 mean to do? Go up 2. So you can come over to the graph and you can count 1, 2, 3, 4 to the left and 1, 2 up. Or you can use the method where you add and subtract from these ordered pairs. Since we want to go left 4, I would -4 from the x parts of the ordered pairs. And I would add 2 to the y part to take it up 2. So A prime is -510. And B prime is -9,8. So -510 would be right up here. Here's A prime. -9,8 would be right here. So there's B prime. Make sure you are not only labeling your dots, but you are actually connecting them together. If you are not connecting the dots, or you are not labeling the dots, you are not getting full credit on the question. Please make sure to take advantage of easy points. Connect your dots for full points. Now map A prime B prime to draw a double prime B double prime after a reflection across the x-axis. When we reflect across the x-axis, x stays the same and y changes signs. So for A double prime, x stays -5, but y becomes -10. For B double prime, x stays -9, but y becomes -8. So -5, -10 would be right down here for A double prime. -9, -8 is right here for B double prime. And then we grab our straight edge and connect those two together. Make sure if it's a double prime, you're putting the double prime with the letter. You're not just labeling it A. Point A is right here. This is a different point. This is A double prime. Make sure you're connecting the dots together. One last thing I want to mention. Translations, reflections, and rotations are all forms of rigid transformations. They do not change the size of the shape. When you take your original figure, whether it's a line segment or a triangle, and you translate it, or you reflect it, or you rotate it, it shouldn't get bigger and it shouldn't get smaller. If it gets bigger or smaller, you've made a mistake. They should stay the same size. Yes. What else would you guys like to see? What else would you guys like to see? We'll work through any of the problems on the homework, on the test review that you would like to see me work through. Number 2 sounds good. Let's go look at number 2, front page. Woo. Tracing paper can come in really handy on a problem like this. I would highly recommend using it. You can have as much tracing paper tomorrow as you want. Part A, which figure or figures in the diagram is a rotation? A rotation is a turn. A rotation is a turn. So I'm going to trace over figure number 2. I'm going to trace around the orange. I'm going to make sure to get the stem and the leaf. And then I'm going to take that figure and I'm going to start turning it. Now, are there any shapes on here that have the stem pointing off to the side? So I want to keep turning it. I'm going to continue to rotate it. All the other stems are pointing up. Does this match with figure 5? Yes. So figure 5 would be a rotation. Does it match with figure 1? No, the leaf is on the wrong side. What else does it match to? Figure 4. It is a rotation of figure 4 as well. So we have figures 4 and 5. Part B, we want to know which one is a translation of figure 5. A translation is a slide or a shift. No turning, no flipping. So I'm going to trace around figure 5. Notice the leaf is on the left. Trace around my orange. If I slide it over here to figure 1, does it match? No, the leaf is on the wrong side. What about if I slide it down to figure 4? Does that match? Yes, the leaf is on the correct side this time. Are there any others that have the leaf on the left side? Two, but to get 5 to look like 2, I have to turn it. But you're right. If we had that one right side up, that one would also have the leaf on the left. So the only one that is just a slide of figure 5 is figure 4. Which figure is a reflection? So now we're looking at a flip of figure 3. Figure 3 is right here. If I'm doing a reflection, it has to go over a line. So I'm either going to flip it this way, or I'm going to flip it this way. If I take figure 3 and I flip it over this line, would it match figure 4? If I take it and flip it over this line, would it match figure 2? Yes. Figure 5 up here is oriented the same way as figure 4, but this wouldn't just be a flip. That would be a flip and a slide. That would be a reflection and a translation, so I can't include that one. So figures 2 and 4. What else would you guys like to see? Yes. Number 3, absolutely we can do number 3. This is going to have us reviewing a lot of the rules that we learned in this module. You want to make sure that you have these rules down for the test tomorrow. If we are reflecting over the line y equals x, we will switch x and y. So if I take my ordered pair for E, and I switch the x and the y, I have 24 at the beginning and -5 at the end. That is my E prime. If I reflect across the x-axis, the x stays the same. The y changes signs, but nobody switches places. So for E prime, the x is going to stay -5, but the y changes to be -24. Rotating clockwise, this way is clockwise, 270 degrees. That is 3 quadrants. If you struggle with, clockwise and counterclockwise, even if you don't struggle, if you just want to make sure you're doing it right since it's the test, you can always look up here at this clock right above the door. If you spend just a little bit watching that red second hand tick around, that is going in a clockwise direction. So clockwise is this way. The rule for rotating 270 degrees or 90 degrees is to switch x and y, and then to match the signs to the quadrant you end up in. So I'm going to draw a real quick XY axis. Our point E, -524, is over here in quadrant 2. 270 degrees clockwise, 3 quadrants clockwise, moves me down here into quadrant number 3, which has negative x's and negative y's. So for my point E prime, the first thing I do is I take this ordered pair and we flip the numbers around. So 24 and -5. And then I have to match my signs. We said down here the x is negative and the y is negative. So I come over to my ordered pair. The x right now is not negative, so we're going to make it negative. The y is already negative, so I'm going to leave it alone. Part D, we're going to rotate counterclockwise, so backwards now, 270 degrees. That's 3 quadrants. So again, we're going to switch X and Y, and then we will match our signs. So point E is in quad 2, negative 524 is in quad 2. We go counterclockwise, so backwards 3 quadrants. That's going to land me here in quadrant 1, which has positive X's and positive Y's. So my point E prime, I take my original point, I flip the order of the numbers, so that'd be 24, negative 5. We said we are landing here in quad 1, which has positive X's and positive Y's. The X is already positive, so I leave it alone. The Y is not positive, so we force it to be positive. Part E, thank you, Talia. Down. We are rotating counterclockwise, so backwards 90 degrees. That is 1 quadrant. 1 quadrant has the same rules as 3 quadrants. We switch X and Y, and then we match our signs. So here's my XY axis. Here's my point E. We are going to go counterclockwise 90 degrees, so that is backwards 90 degrees. It puts me down here in quad 3, which has negative X's and negative Y's. That is exactly where we landed up here in part C. So it's going to have the exact same ordered pair as part C. So E prime is negative 24, negative 5. Part F, we're going to go 180 degrees about the origin. It doesn't matter whether it's clockwise or counterclockwise. We will leave the numbers in the same order, but we will change both signs. So my point E prime, I leave my numbers in the same order, but this negative 5 becomes a positive 5. The positive 24 becomes a negative 24. And then the last one on number 3, it says map point E to point E prime using this right here. This is a translation. The first part tells me to add 11 to all of my X's. That will send it right 11 units. The second piece tells me to subtract 9 from my Y's. That will send this point down 9. So we take the point E, which is negative 5, 24. We're going to add 11 to the X, and we're going to subtract 9 from the Y. What is negative 5 plus 11? 6. And what is 24 minus 9? 15. So E prime becomes 6, 15. What else would you guys like to see? Which one? Number 5? Absolutely, number 5. Graph and label the following figure and its image. The figure that they want me to graph and label is triangle CDE, and they gave me the ordered pairs right there. C is negative 2, 2. D is negative 1, 4. And E is negative 6, 3. Then I use my straight edge. I connect those points together to make my original triangle. Says we are going to rotate the triangle clockwise, that's this way, 90 degrees, so 1 quadrant. So my triangle is going to come around into this quadrant over here, which has positive x's and positive y's. So we need to switch x and y. And then we need to match the signs to the quadrant. So I'm going to switch the numbers around. So for C prime, that would be 2, negative 2. X's and Y's are both positive, so I make my X and my Y both positive. So 2, 2 is C prime. For D prime, we take our two numbers and flip them around. So I have 4, negative 1. But we landed in a positive, positive quadrant, so the 1 becomes a positive. So 4, 1, right here, is my D prime. I forgot to put the prime on my C. Let me do that. There we go. And then E, we flip the numbers around, so that becomes 3, negative 6. But we want positive X's and positive Y's, so we make the 6 positive. So 3, 6 right up here. There's E prime. Grab my straight edge. Connect my dots together. Make sure that your triangle is not changing size. Make sure you connect the dots together between the points. Make sure you label the dots, not just with the letter, but with the prime that it needs. What else would you guys like to see? Number 6, absolutely. Let's go look at number 6. Using the triangle FGH, graph and label its image after the reflection over y equals negative 2. So the first thing they give me, these 3 lines right here are for F, G, and H. This is not for a transformation. This is for me to write down the ordered pairs for the triangle that's already printed here. So F is at negative 5, 0. G is at negative 2, 5. And H is at 1, 2. We are going to reflect over the line y equals negative 2. So we will find negative 2 on the y-axis. That's right here. And then we will draw a horizontal line through that point. It has to be horizontal because if I went vertically through that point, I'm going to go through all the numbers on the y-axis, but I only want to go through negative 2 on the y-axis. That's why it has to go horizontally like this. Y equals negative 2. There's a negative 2 right here, but it's on the wrong axis. Going like this would be going through x equals negative 2 because that's the x-axis that I'd be cutting through. Now we are going to count how far away our points are from that line and go the same distance away on the other side. So point F is 1, 2 hops away from the line. So 1, 2 hops on the other side. Right here is my point F prime. That falls at -5, -4. And then we'll do G. 1, 2, 3, 4, 5, 6, 7. So on the other side, we go 1, 2, 3, 4, 5, 6, 7. Right down here is G prime. That lands at -2, -9. And then we do H. We are 1, 2, 3, 4 units away. So 1, 2, 3, 4 units away on the other side. There's H prime. That landed at 1, -6. And what do I still need to remember to do, or else I don't get full points? Connect the dots. Connect F prime, G prime, and H prime to make a reflected triangle. Triangles should not change size. What else would you guys like to see? We have time for 2 or 3 more problems, depending on how long they are. Time for 2 or 3 more problems. Number 11, absolutely. Very back page. We want to identify the rigid motion as either a translation, this is a slide, or a shift, a rotation, which would be a turn, or a reflection, which would be a flip. Thank you. Translations, the ones that are slides or shifts, these preserve orientation. So what I mean by that, when I say it preserves orientation, if I look at this first picture here and I look at the shape that doesn't have the primes, I look at my original. Do you guys see how C is on the left and D is right 2 up 2? When I look at the transformation, C should still be on the left. Is C still on the left? So that did not preserve orientation. Looking at this one, the one that does not have the primes is the one on bottom. X and Y are directly across from each other with X on the left and Y 6 units away on the right. Are X prime and Y prime in that same position with X on the left and Y 6 units away on the right? And then see how Z is 2 down and 1 left from Y? Is Z prime 2 down and 1 left from Y prime? So orientation was preserved. This one is a translation. It's a slide or a shift. Reflection is a flip. Which one of these 2 leftovers looks like it was flipped over a line? First one. This is a reflection. It has flipped over this line here. So this is a reflection. Which means this one over here has to be a rotation. A rotation is a turn. Point B had been on top, but then it rotated around to be on the left. A and C were both on the bottom with A on the left and C on the right. Well, then A rotated around to the bottom and C rotated up to the top. It turned. When you're checking for rotations, I would highly recommend using that tracing paper because you can turn the paper and see if it matches up. Right? What else would you guys like to see? What else would you guys like to see? Number 4, sure. Let's go look at number 4. Number 4 says graph and label the following figure and its image. Here's the 3 points they give me for the triangle, C, D, and E. So we're going to go and plot those points first. C is at 4, -3, right here. D is at -2, -5, right down here. And E is at 1, 0, right here. Connect those dots together to make our original triangle. Then it says under the translation, and it gives me this to describe the translation. So my x's, I'm going to -3 from all of the x's. That will send it left 3. For the y's, we're going to +7 to all the y's. That will send it up 7. You are welcome to just come over here to these points and count left 3 and up 7. Left 3 and up 7. You can absolutely do it that way. Or, if you prefer, you can use the ordered pairs, and we will -3 from all of the x's and +7 to all of the y's. So that would give me C prime as 1, 4, right here. D prime would be -5, 2, right here. And E prime would be -2, 7, right here. And then we grab our straight edge and connect those dots together to make the translated triangle. Make sure that your transformed shape is not changing size. All right. We've got about 5 minutes left, which is enough time for one final problem. What last problem would you guys like to see? What else would you guys like to look at? Yes, number 1, absolutely. Problem number 1, graph and label the following figure and its image. Here's my 3 points to make the triangle, C, D, and E. Point C is at -5, 2, right here. D is at -1, 6, right here. And E is at 1, 3, right here. Then we grab our straight edge, and we connect those points together. We are going to be rotating this 180 degrees. It does not matter whether it's clockwise or counterclockwise. That is 2 quadrants. To rotate 180 degrees, you leave the ordered pair in the same order, but you will change both signs. So C was -5, 2, which means C prime is +5, -2. D was -1, 6, so D prime is +1, -6. And E was 1, 3, so E prime is -1, -3. So 5, -2 would be right down here. There's my C prime. 1, -6 right down here, so there's D prime. And -1, -3 right over here for E prime. Then I grab my straight edge, connect those points together, and it makes my rotated triangle. Does anybody have any last questions? Any last questions? All right. Answer key is posted in Canvas. If you go to Canvas and you go to today's date in Canvas and you scroll down, you will be able to find videos for all of the classes that met earlier today. Period 3 will be going up right after school. Down at the very, very bottom of the page, you can click right here and it will bring up the answer key with all of my work. Be turning in this test review tomorrow when you come in to take your test.